So looking at the implementation of k-sets, you have basically a struct list head list, which basically well tells you that it's probably implemented as a linked list again. So the list is a linked list that of all k objects in this k set basically. So you have the k set implemented as a linked list, and you have a list lock as a spin lock that protects basically this entry in in this list. So you will have well since the k set is just one instance in the linked list, right? So I have a spin lock for this entry in the list. And then you have key object, which is a key object representing the base class for this set. So what kind of key objects is this? And you have something that represents the hot plugging mechanism if it's supported. And hot plugging is basically when you plug in your USB stick, you basically get the hot plugging mechanism up and running for you because it loads directly without doing anything, and then the hot removal is just when you remove it. Versus, for example, if you're running your computer and you try to take away your memory, for example, or one of your memory cards, you cannot do really that without breaking up everything, right? If you have multiple memory cards. So putting everything together, so you'll have sub. Well, you have k objects, multiple k objects that are basically all in linked in a k set, and this k sets together will form linked the subsystem that you're basically trying to describe. So you most of the time, as I said, you will not deal with k objects at all. You will basically deal with some wrapper classes on top of them, or some abstraction layer on top of them, like cdev.h, for example. Let's talk a bit more about sysfs. We just mentioned it briefly. Sysfs is an in-memory virtual file system that provides a view of the k-object hierarchy. So it tells you about all the device drivers that are, or all the devices that are abstracted in your system. I talked about the initial purpose, that was for power management, and then it basically became a replacement for device related files that previously ended up in slash proc. And you can uh, have a partial view of the sysfs file system as is mounted at slash sys. And this is where what I basically was doing wrong today in the lab is that I was doing a slash dev, and slash dev sysfs is a file system that provides the whole abstraction, while slash dev is actually the device drivers loaded. So this fs provides you, so slash sys provides you with an overview of all the modules that are running in a very tree nice structure, while slash dev has the actual stuff. So the root of the sysfs contains at least 10 directories. Yeah, just just to note that this is basically again now replacing what using slash proc. One thing to note for your projects, if you use slash proc, I will accept your solution. If you find that slash proc is better, use it for you, for your purposes basically. uh, so sysfs, there are at least 10 directories. The first one is block, and it contains one directory for each of the registered block devices on the system. And well, you know what the block devices are. One of them would be your CD-ROM, for example. Each of those directories in turn will have the partitions on the block device. So because you might have, I mean, well, your CD-ROM is not partitioned, but your USB stick might be partitioned. Bus provides a view of the system buses and what is connected to the system buses, so you can actually go through it and see what is connected through the different buses in your system. Uh, yeah. Class contains a view of the devices on the system organized by high-level function. So class is more like the high-level overview of how the whole system looks like. Dev provides a view of the system buses again. Devices is a view of the device topology of the system. It maps directly basically to the device structure inside the kernel. and this will have yeah, in this one you'll have even the virtual devices. And then you have firmware that contains system specific tree of low level subsystems, because well, not all not all architectures are the same, so you have some system specific functionality, and this will be basically going into the firmware. FS will give you a view of the registered file systems, and here we're talking about the real file systems that communicate with your hard disk, for example. And kernel would actually show you the kernel configuration options and some status information. So the root of the sysf yeah and then there's modules, which contains a view of the system's loaded modules, and this is probably where you can load your module also, or you can find your module. And power, that contains the system-wide power management data. Some system will have more or less directories, so this is what you will find on x86 normal Linux. You might find a bit more or a bit less depending on the architecture you are running on. /sys/devices is kind of the most important directory in all of these. Many of the other directories that are there are just a reorganization of this one. So basically, if you look at, for example, bus, it's basically /sys/devices has all the devices, while the the bus folder, the bus directory, basically contains what is connected to the different buses from these devices. So in many cases, the other directories are just reorganizations of this one, and it has just a symbolic link to the contents in the device's driver. One useful thing to do is basically you can navigate through the different interconnections between the high level concepts in class, for example, versus low level physical devices and devices and the actual drivers in the bus So you can basically have the full system overview. So what classes of devices do you have? What are the actual devices that you have? And what is connected to the bus? Use the different directories to basically navigate through your kernel modules and devices. sysfs is the file system is currently the place for implementing functionality. If you want to basically use, I mean, this would be the preferred place to use for your project. It is what is used mostly right now, but as I said, I will accept any solution that is correct using /proc or IOCTL. Okay. These are some examples for your project. Again, this is a guy, for example, who had made a system module that's called prank that would override what your if you try to play an MP3 with this module loaded, it will always play one other MP3. And that of course you need to have on your system to be able to play. Similarly, if you try to open a JPEG file or file with a photo, it will basically show you another photo. So if you try to open up your personal photo, it will show you another photo. You can actually load this on your not on your computer, and I hope not on the lab's computer, because that will not be fun, especially if you start doing nasty stuff. I'm not going to hint more about what nasty stuff you can do, but you can prank people using this, and that's basically the whole purpose of having this. And the code is online, so you can check it. I have to note there are 10,624 files in the kernel that include linux.module.h, which basically means that you have a wealth of information in the Linux kernel on how to implement modules that actually run. Now, these modules, these LKMs, are now compiled in kernel space. You can just look at them and for inspiration, but if you want to do testing faster than recompiling the kernel every time, then the easiest way is to compile LKMs in user space and attach them to your kernel. There are some instructions and some documentations in /documentation/kbuild on how to build actually some this kernel modules. There are some example at /documentation/input/input programming on how to again implement kernel modules. I'm just trying to open up things to look at. There are 3 of you in each group, so I hope that you basically read these and share information among yourselves. Or, I mean, you can either read them together and try to decipher them together, or the other way would basically to split the work among the 3 members of the project. Okay, I just, yeah. And then these are again more examples to look at. So someone was trying to create a module creating lost in first out device, and this is actually a lab from University of Michigan where they actually were working on Raspberry Pis. I believe not Raspberry Pis 3, so Raspberry Pis 2, to actually implement Linux kernel modules on Raspberry Pis. So that should also hopefully be helpful. I have been thinking about if I should point you to this or not, but I realized that, well, for people who would like to read a bit more about a similar project, they can read about the Unbuckle project. It was a project that was done in Cambridge, where they actually did not just implement key value store, but implemented a memcached. Well, they relinked memcached into the kernel. Well, they have made some different design decisions. It's a long read, it's a nice read, but I'm not sure if it will be helpful for everyone. So if you have some time and you would like to see how people are playing with these things, you can basically look at this project Unbuckle. And by the way, the code is open source, so you can actually take a look. With this, I conclude. Thank you very much. See you tomorrow, and have fun Linux kernel hacking.